All right, exam review, pre-calc A, literally going backwards, starting with number 50. So let's go. This says if Kramer's rule is used. So good news is you don't really have to use Kramer's rule. You just have to know how to get it started. So this says dz, which just means take the constants and replace all the coefficients in your z column. So if I was to look at this initially, it would be 1, negative 1. There is a 1 here, but I'm replacing it with the 0. This has a 2 in front of the x, so there's 2. There is no y, so there'd be a 0. The negative 3 would be replaced with the negative 1. There's my 3. There's my negative 7. And then my 4 would replace my 5. And then I go on the hunt for this. And it's looking like it's right here, letter C. Number 49 does not tell us specifically what method to use, and you guys are on a final exam, so really just get it done. I'm going to eliminate the x column by doing this. So I get 6x plus 15y equals 48. Negative 6x plus 14y equals negative 48. So then we add these together. These cancel. We get 19y equals 0. That's pretty easy. Divide by 19. And we get 0 for our y. Now we just have to plug that back into either one of these. I'm going to plug it in here, so that would cancel this. So I'd get 2x equals 16. Divide by 2, I get x is 8. So that'd be letter E. All right, so number 48 is a little bit of a stinker. If you were left alone, in other words, if you didn't have this multiple choice option. When I first glance at this, it says which row operation can be applied to this to obtain this. First thing I'm going to say is, well, which row's been changed? You can see that row 2 is the only row that's been changed. So we know it's going to be plus R2 because this is how we know which row changes. Now, I can see this doesn't make any sense, but anything plus R2 is going to be in our realm of possibilities. So really what that does is it whittles it down to 2 possibilities. So I'm going to try with this one because this one just looks easier to try. So 2 times the third row plus the second row. So that'd be negative 6. So if I actually multiplied this by 2, that'd be negative 6 plus 4 would give me a negative 2. That's not what happened. So I can eliminate that just on the first step. Looks like this is the right answer by process of elimination, but let's just prove it. We got to multiply 4 thirds times the third row, so 4 thirds. So this would be negative 1. They'd cancel, make negative 1 times 4 is negative 4, plus 4 is 0. That looks winner, winner, chicken dinner. So 3 goes into 6 twice, 2 times 4 is 8, 8 plus 7 is 15, and you can see that it just works. So that would be our answer for number 48. Taking advantage of the multiple choice. 47, identify the matrix obtained if the row operation 3 halves R3 added to R1 is performed. In other words, we can go on the hunt by eliminating, again, take advantage of the multiple choice. Just by the way it's written, we know our row 1 is the only one that's going to change. So if we can see that there's a 1, 6, 2, negative 3 in any of these options, we can eliminate it. So we can eliminate this because you can see the first row did not change. So we got 3 things we need to look into. So we're literally just going to do it. 3 halves times row 3. Now what I'm going to do is I'm going to call 3 halves 1.5 and then do some mental math. So with this, I know row 2 is not going to change, and row 3 is not going to change. So now I'm going to just follow this order. So 1.5 times row 3, so 1.5 times negative 1 plus 1 would give me a negative 0.5. 1.5 times 2 is 3. 3 plus 6 is 9. 1.5 times negative 3 is negative 4.5 plus 2 is negative 2.5. And then 1.5 times 4 is 6. 6 plus negative 3 is 3. So I need to look for that. And I see it right here, as long as this matches this, which it does, and this matches this, which it does. So there's my answer, letter B. Okay, number 46 is so easy that some of you might try to make this hard. All you need to do is find the element, that's what this E stands for, in row 2, column 3. Well, row 2 is right here, column 3 is right here, so that would be your element, Z2. It's that easy. Number 45, it's a 2 by 2. How do you evaluate a 2 by 2 determinant? You multiply this way first, subtract always, and that'd be minus a negative 3, so it's negative 2 plus 3, which is 1. Letter C. All right, number 44. This is asking us to find the inverse matrix of this. So the formula would be this, and then I'll show you what to do. So the first thing we have to do is find the determinant of A, and that would be negative 2 minus 3, which would be negative 5. So this would be 1 over negative 5. But then what you do is you flip these two. These don't go anywhere, but you take the opposite of them. Then you distribute this to this, this to this, this to this, this to this, which would give us 1/5. 1/5. All right, don't know if you were listening really carefully. If you were, you noticed I made a little mistake. Negative 2 times negative 1 is not negative 2. It's positive 2, which would make a huge difference. Minus 3 would give us a negative 1. So instead of this business up here, I'd just have 2 minus 3, which would be 1 over negative 1, which is just negative 1. And then I go ahead and switch things around. So I'd switch these and take the opposite of those. And then just distribute the negative 1 to everything. So I'd get 1, 1, 3, 2, which is letter D. All right, move on to number 43. This says multiply matrix B times matrix A. Kind of a bummer, because I told you guys make sure to literally switch those if they do that to you. So 0, 1, negative 2, 6. There's B. Going to multiply it by A. 6, 1, 2, negative 3. So I'm going to multiply this row through that column, and that answer will go in the upper left-hand corner. So that's 0 plus 2 is 2. Now, what goes in the upper right-hand corner? I'm going to throw this row through this column. That's 0 plus negative 3 is negative 3. I go to this row, throw it through this column, so I get negative 12 plus 12 is 0. This row times this column, negative 2 plus negative 18 would be negative 20. And I go on the hunt for that, and it looks like that matches up with letter A. Number 42 just has a little bit of work. First thing we got to do is double matrix A, so it's like we just double everything. So that would be 6, negative 4, negative 2, 2. And then I have to subtract the result after I multiply B by a 4th. So I'm going to put a 1/4 out here. This times this would be negative 0.5, because it'd be 2/4. This times this would be 0.25. I'm just going to convert it to decimals, because 1/4 times 1 is 0.25. 1/4 times negative 4 is negative 1. 1/4 times 2 would be 2/4, which is just 0.5. Now I have to do the subtraction. What's 6 minus a negative 0.5? That'd be 6.5. What's negative 4 minus that? Well, that'd be negative 4.25. What's negative 2 minus a negative 1? That'd be negative 2 plus 1, or negative 1. 2 minus 0.5 would be 1.5. And then I go on the frantic hunt looking for that. And you can see a lot of close answers, but they're not available. So that'd be none of the above. Definitely possible, just none of the above. All right, good old Demoivre. All right, so I took a second and wrote the formula down that we're going to use. R, what's R? Radius. What's N? N is this power. So you can see we're just going to put the N, 6 there, 6 there, 6 there. We also have to figure out the theta. Now, where does that come from? Well, this is the same thing as going left 1 and then up 1. Because this was our real x-axis, and this is our imaginary axis, if you recall. And this is our spinner, or our vector. And so what we have is a 45, 45, 90, so this is the square root of 2, which is our radius. So that's the square root of 2. We know that n is always the power, so that's to the 6th. Cosine of n, which is 6, times theta, which is how far you spun your spinner, which is 135, plus I sine, and it turns out to be the same thing. So I'm going to do the math for this up here. So square root of 2, 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 square root of 2. Every pair will produce a 2. So that's 2 times 2 times 2, which is 8. And then I got to go to this business, which is 810. I'm just going to write it like this. And I need to think for a second. If I go around, that's 360, and if I go around again, that's 720. And if I go 810 minus 720, that leaves me with 90 degrees. So what that's saying is I need to figure out the trig functions at 90 degrees. So I need to find cosine of 90, and I need to find sine of 90. So what I do is I think to myself, okay, at 90 degrees, what side disappears? That would be my adjacent side, which means cosine of 90 would be 0. So I know that this 8 comes from this, so it's really 8 times 0. And then I know that sine, there's my opposite side, there's my hypotenuse. Those two things are the same and they're positive. So that's sine of 90 degrees, which is the same thing as sine of 810. And you can type that in your calculator. You're on an exam, for Pete's sake. Would be 1, so that'd be 1i. Distribute, and all I'd get is 8i. Technically, it's 0 plus 8i, but as you can see, letter C is waiting for us to circle it. All right, number 40 is very similar to number 41, but we don't have to use Demoivre. First thing we're going to do, if we're going to find the polar form, which all of these examples are polar form, you can see we need to find r, because that's what goes in the polar form here. And how do we find r? Well, r stands for radius. If we go -6 to the left and then we go up 6, you can see another 45, 45, 90, and this has to be 6 square root of 2, and that's my r. So I can eliminate this, I can eliminate this. It's not negative, I can eliminate this. So I'm down to D and E, so I just need to figure out how far I spun my spinner. Well, if this is 45, this has to be 135, and you can see 135, 135, letter D. Okay, try to squeeze number 39 in before this 15-minute limit runs out. So you can see it says find the product, Z1, Z2, but then it gives us a little extra work to do in the end. But what we're going to do is look at the formula. When it says multiply Z1 times Z2, you start by multiplying the R's. So what's 1/3 times 12? That'd be 4. But then the formula also says to add these. So it'd be cosine of 150 plus I sine of 150. Now, if it said leave it in trigonometric form, we could be done. But it says keep going. How do you keep going? You spin your spinner 150. So it'd be 90 plus 60, leaving you with a nice little 30-degree reference angle there. So this is 1, this is 2, this is negative square root of 3. So we'd go 4. What's cosine? That'd be adjacent over hypotenuse plus I times sine of 150, which would be 1/2. Distribute, we'd get -2 square root of 3 plus 2i, which would be letter D.